Can I say something into it?
Testing. 1, 2, 3. Yeah, beautiful.
Okay. Great.
Cool.
Ready to start on you?
You ready, or do you want to wait a little bit more for Charlie?
Well, I get started. So,
Just go to. I gotta click through and decide.
Yeah. Okay, we'll be getting the workshop started now. Before we start, I'd just like to acknowledge the traditional land on which this workshop is taking place and any elders past, present, or emerging. We're CISSA, we run lots of social, educational, and industry events for comp sci students. This is our link if you aren't already a member of the club. Feel free to scan the QR code. Yeah, just give you a moment if you want.
beautiful. So, hello everyone. I might just take a moment to introduce myself. So my name is Rob. I have been tutoring the subject for quite a while. Not tutoring it anymore. So I'm actually working in industry as a software engineer. And worked out well to get there. So before that, I was probably doing this for a couple of years. And then I'm also going to be joined by Charlie, who's just running a few minutes late. So he's going to be the other sort of speaker for today. And our real plan is just to discuss maybe some of the concepts. So we were planning to do a bit of a recap, and then we can do a deep dive into anything that students have any questions about. But really for today, so we've got 2 hours, definitely want to cover some exam questions. We're here to assist. So if anyone has any particular questions or problems that they're having, it's a really good time to sort of mention it. We can talk about it now. Other than that, we also are here to help. So if you have a question, and it's more than likely someone else has the same question. So it's a really good opportunity just to discuss. I do have a bit of an agenda and we can stick loosely to it, but nothing's set in stone. Like if there's something else that's more important or that you want to spend more time talking about, just mention it and we can go. Right, it's a pretty closed group. And so we've got 2 hours to just cover all of the problems or any questions that you have. Okay, any questions around that? Are we happy? Do I need to wear this microphone or everyone can hear me? Yeah? Okay, so as I said before, trying to keep it a bit relaxed. But what I wanted to do and to get us started, I think what's going to be kind of handy is maybe just a bit of a mind map of everything everyone knows in the subject. So I kind of want you to throw out anything that you've learned here. I'm going to chuck it on the whiteboard and then we're going to have a discussion about it. Part of that is we can also highlight things that you don't quite understand or things that you want to talk more time, like take more time to talk about, and then we can just go through and talk about it when the time comes. So I'm going to be typing as everyone's throwing out answers. If you don't know, it's fine. Like we're here to do it together, but I'm really just trying to keep this more as a conversation than me spending 2 hours talking to everyone. Okay, that being said, what is something someone knows about the subject?
Use cases.
Yeah, beautiful. Okay, do we have anything else? Yeah. Design patterns, beautiful. Grasp. Yeah. So there was 2 things there. Hang on, what's going on? Grasp. Why is this not working? Grasp, and there was something else? Gang of 4. Beautiful. Anything else? System sequence diagrams. Perfect. And there's maybe another one here. So I'm actually really glad that you brought up this sequence diagrams and in particular this word system. So I think one confusing thing about this subject is this whole notion of system versus non-system. So we'll talk about it a little bit here. But when someone throws out system sequence diagram, is there anything else that's kind of comparable to a system sequence diagram that you've learned? Yeah. Yeah, design sequence diagram. Perfect. And we're going to spend a bit of time talking about these 2. Anything else? Yep. State machines. Perfect. I'm trying to get like the list of everything, so keep it coming and then we'll talk about it. Technical memo. Whoops. All right, anything else? Yeah, perfect. Architectural analysis, beautiful. Yep. Yeah. So let's put it down here. And we can talk about that. Anything else? So I've maybe got a few, but let's talk about use cases, right? Is there something else that goes with use cases? Like maybe a high level concept that we show them all together rather than just a single use case? It might be like a what, sorry? Yes, but I was actually looking for something else. A model, yeah. So use case diagram is the terminology I was looking for. Perfect, and we can talk about that. But use cases, use case diagram. So we've got domain models, we've got sequence diagrams, system sequence diagrams, design patterns. Do we have domain model in here? So static design model, is this the same as domain model? Oh yeah, perfect, thank you. It's going to make a lot more sense, I promise. We're going somewhere here. Okay, perfect. And then let me just check. So system sequence diagrams, which is the same as design sequence diagrams. Right. And then there's one more. So a communication diagram. Is this something that anyone's heard about before? It's probably in the supplementary material. So we'll chuck it on here just for completeness, but it's something that you might get asked, you might not. So there's something called a communication diagram. And then what I'm looking for is there's a bit of a link. So I'm just going to shift these two down. We've got a communication diagram, and we've seen this notion of system in front of something before, right? So there's also something called a system communication diagram. Okay, perfect. And let me just check. I think that's probably enough to get us started for the moment. So we've got state machines. Yeah, cool. And we've got graph, gang of 4, development lifecycle, architectural analysis, unified process. Okay, perfect. So now what I want to do, and I think this is hopefully valuable to everyone, but if it's not, feel free to tell me and we can skip it. I'm going to drop 2 headings here. So there's 2 things I want to quickly talk about, and I think this is really important when it comes to particularly this subject. So there's kind of 2 big aspects of things that we learn. One I kind of call the problem space, and this is all about how you describe the problem that you're solving in this class, right? So it has things like users and interactions with the system, and then there's other things that pop up, right? So there's this concepts, or these concepts of things that sit into like a problem space. So they describe the actual system and the problem that we're solving. And then if we jump across to solution space, we start talking about how we actually solve that problem. So this is jumping into code and design patterns and how we actually code it up and run a system that will meet that problem. And so everything that we've just learned is can be broadly categorized into these 2 things. And you'll see that there's some crossover, but there's also things that belong in problem space that don't belong in solution space. And I'm bringing that up because one of the most common mistakes I kind of see is getting these 2 mixed up, right? So someone's giving me a problem space solution and there's code in there, or someone's giving me a solution space and they're referring to a user, right? These are things that you don't do because one describes a problem, one describes a solution. Okay, so with that in mind, let's quickly pick this one, use cases. What does everyone think use cases is about? Problem space or solution space? Problem space, yeah, exactly. So a use case, and this is what's quite important, it describes how you interact with the system to achieve an outcome, right? So there's kind of 3 different modes, and we can talk about it. But with use cases, it's going to be a series of documentation, a series of steps, and it's all about a user interacting with the system. The user clicks a button, a user does this, and then this will be the result, right? So very quickly, we can talk about use cases. So there's just three different types. I think it's brief, casual, and fully dressed. Right, and these are just the kinds of use cases or the kinds of styling. But what they do is they always describe how you interact with the system. And so what's really important here is words like user belongs in problem space. And then hopefully I've got it, but like a little stick figure. Okay, never mind. Let me just grab it. One sec. Okay, so the other thing that belongs here is a stick figure of a person, right? We're in user space. It makes sense for users to be interacting with the system. And so having a user and a user uses a use case that address an outcome, all of this makes sense. Next one, use case diagrams. Very, very similar, right? So a use case diagram is just a collection of use cases. And I might just quickly spend a bit of time talking about this, because you might very likely get asked to do a use case diagram. But one of the very common problems we see is the actual difference between use case and a diagram. So can someone quickly tell me what's the appropriate level of detail on a use case diagram? Like, is it a very high level description of the problem, or is it going to be much more detailed, like the user logs in and then he does something else? No, right? So I'm seeing some shakes, so I was replying to that. But what I want to sort of call out here is a use case diagram is just a one-page visual or like a small little diagram of all the important use cases. So when you have a use case, you might have multiple details, like the user logs in, he does something, then there's a secondary, like a third party that interacts. All of this would just form one use case. So use case diagram, you're just going to have one little bubble. That's not a bubble. One little bubble per use case, right? And so the actual description of the use case will pop in here, but then the use case diagram, let me just get rid of that fill, will be like a very high level description of what goes on, right? So I might have use case one. I'm not that creative, so use case one could be something like the user goes to the system to place an order. Use case two might be that same user goes to the system to cancel an order, right? They both have very different outcomes, and I can write a full detailed step about how that happens. But when I draw a diagram, it's just one little bubble on the diagram. And the other thing, why I'm mentioning this, is I've drawn this box here. Why would I want to put a box around the use cases? Yeah?
The system.
Perfect, yeah. So it's the system that we're talking about. So you might see this word system, SUD, system under discussion. What it means is that the system is just a black box, right? And we're coming back to this thing, we're talking about problem space. I'm not talking about how the system works or what it does. I'm just talking about the system as a black box. And so you'll never ever see details of the system like a database or something in the problem space, but you will see things like the actual user. So it makes sense for a particular stick figure to be interacting with these diagrams and be doing stuff, right? Because this is a user interacting with the black box that is the system, right? So here we just talk about system, which is going to be like a black box. What it actually does, the components, how it works, we don't really care yet. We all okay with everything I've been saying? Yeah? Okay. So let's maybe pick the next one. I'm going to pick this one. System sequence diagrams. What is this? Or where does it belong? Problem space or solution space? So I think here there's a pretty easy way to kind of figure it out. When it says system, it's talking about the system as a black box, right? So here, a system sequence diagram belongs in problem space. And what's really nice is that there's an associated thing that's very, very similar to this, but it's not called a system sequence diagram. It's just called a design sequence diagram, right? So as you can imagine, maybe the design sequence diagram is equivalent, but it does something a little bit different. And so we end up with, these two here. So system sequence diagrams is talking about the actual system. It's appropriate to have figures in there. Design sequence diagram is talking about implementation detail. So you don't have a user and you don't see stick figures. Is that clear to everyone, like why I'm making this distinction? So if you give me a diagram on your exam and I've asked for a design sequence diagram, or otherwise also just called a sequence diagram, and you put in a stick figure, that straight away tells me that you don't quite, like, you're giving me the wrong thing, right? So you don't have stick figures in solution space, but rather you would have more details. Like here, we talk about the internals of the system, right? So things like databases make sense, things like APIs make sense. You know, I'm getting more into the nitty-gritties of how I actually implement this thing. Okay, perfect. So does that kind of make sense? Do you want me to talk about system sequence diagrams anymore, or we're okay? Yeah.
I feel like we're seeing a little bit of useless.
Yeah, like they're very high level. They just says someone does something and then that's it. So you'd be exactly right. It is maybe useless from a technical implementation perspective, but it becomes quite important because it establishes how people interact with the system. So this kind of problem space, and I know like maybe we're all here because we love coding, but it's really important to describe how your system works for non-technical people. And so the whole, I think like maybe the whole point of this and why you've spent some time studying the problem space and the solution space is you go on this journey, right? Someone tells you what they want, then you go through the process of, okay, how will it work from their perspective? And then once you have that, then you can code it up and you can build a system that you're guaranteed to meet those requirements.
I have to say that I feel like the ones we've done, they're not much more than just a set of dot points. There's kind of adding arrows between the first one.
Yeah, perfect. So, and that would be it, right? So maybe we can dive into an example here, but I was saying before, right, like the system's a black box in these diagrams. So I'm just gonna paste this because I came a little bit prepared, but we talk about interactions with the system as a black box. What happens in that system, we don't really care, but I would have a user. So I might have, you know, like a little stick figure here. Let me just, stick figure here that comes across, talks to the system in some sort of way. And we would call the stick figure like an actor. Does that terminology remind anyone? So the actor would be here, then obviously there's a bit of a timeline. And then what the system does will be documented here. So, you know, like at a very high example, the one that I've sort of got here might be like an Uber driver, right? So me being the actor, I try and book an Uber. I don't talk about the Uber internals and how they actually program it up, but I just say I come in here and I want to book a ride. You know, so very high level, just talking about the actual implementations. Then what will happen is the system might do some other stuff, right? So it'll probably respond with a price, and just for time, maybe I can copy that, but we'd do something like come in here or try and book a ride. Let's try and get our verbs probably. So then you get a price, then you look at the price and you go, okay, yeah, that's fine, book in the ride. But now maybe the system has to talk to a third party, right? So here I probably want to go to like a bank and actually withdraw my funds. And so then I would have something like a bank. And then I draw that in. So then I come in here, withdraw my funds, I'd respond, then I respond to the actor, and then maybe I have to go and contact a secondary actor. So like go and contact the actual driver and inform them. So you're right, like the actual diagrams here, very high level, the system's a black box, but I would have my primary actor on the left and then any sort of supporting actors on the right. And there's a bit of terminology. So you can kind of see here, this bank is not part of my system, but it's an external third party. And so I still treat it like the same. So I'd have it here and it's not part of my system, but it's some entity that my system interacts with. So it's shown here. But it's not a physical thing, right? Like if I had a physical person like the driver, then I can show them being an actual person. So then it could be like, okay, the bank works, then I go to my driver and I, you know, inform them, something like that. Yeah, and so it's a very high level, there should be an error there, but it's a very high level kind of overview of what would happen. Yeah.
Is it just the dotted lines go left with solid line arrows?
Yeah, great question. So what you'll see, there's kind of two conventions here. One is the solid arrows is always the way there. It's optional to have like a return arrow, so it'll be dotted if it returns. The other thing that you will see sometimes, and I'll just put it over here, is you'll see something like price is equal to. So you won't have a return, but the return result's implied by the actual arrow. This here is looking a lot like solution space, right? So it's looking a bit more like I'm assigning variable on a return result. And so we try not to do that in problem space because they describe two different things. And so I keep to this convention where I have a response that would be the dotted arrow.
Just
Yep.
add on there from that question in terms of.
Oh yeah, this is Charlie, everyone.
Sorry, I didn't introduce myself, guys. So talking about that, you mentioned before that, is it just any arrow that comes from the left-hand side to the right-hand side, that's just a dotted line, anything that goes in reverse from the dotted line. It's a little bit more specific than that. It's really important to note that those solid arrows are supposedly there to be indicating a specific action that is being taken. So in this particular case, it is the actor trying to book a ride with the system. There's nothing stopping from the system, maybe potentially, I don't know, querying the user for something, maybe prompting them to input payment details or something of the like, and the user responding back with those payment details. There's nothing wrong with that. It's just to make sure that you guys know that that solid line is there to indicate an action. The dotted line is to indicate that response backwards. Does that make sense? I don't know who asked that.
Yep. Yeah, perfect. So excellent question. There's a notion of a semicolon here, and there's not a semicolon here. So this, I think, is maybe unimportant terminology for exam, like we're not going to deduct marks, or at least we haven't in the past. But it just means that this is like the actual system, or it's like a thing that you're coding up. So your system here is this entity that you're creating, where the bank is like more of a physical entity. So it's trying to differentiate between what's real and what's not. Yeah. Yeah.
That not coding on the actor.
Yeah, correct. So we're in the problem space here, right? So there's not a mention of code, right? You should never use the word code in this. We're not talking about code actor. We're talking about a physical person using your system. In front of actor, like that. Oh, okay. So,
I think to jump in here, this is more so a UML notation. It's not so much that, it's just a factor of the fact that a lot of the things that we're using right now is following UML notation where we can, and as part of the UML notation, whenever we have an entity of any kind, we have that column in front of it. So the reason why we see it in code as well, because we're just using UML notation.
yeah. And I think like maybe just one thing here and what might be confusing everyone. So like software modeling and design, we're really talking about these high level concepts, and there's not like a defined programming language or standard here. So you might hear these words like UML, and then there's different iterations like UML 3 and 4 and conventions, but there's not like someone saying it has to have these semicolons and not. And so, unfortunately, like you might see different flavors. Don't worry too much about that level of detail. Like you can't lose marks because it's not defined, but we try and just pick a standard and use it throughout. And so if there's anything confusing about UML, ask us and we can kind of give direction. But yeah, like you'll see different flavors. And then if you look at the textbook in the next year, it probably might have an iteration there because the UML keeps getting updated. Okay, awesome. So anything about system sequence diagrams, or we're kind of okay here? Yeah?
Can you have more than one primary actor?
Excellent question. Can you have more than one primary actor? Let me ask you the same. Can you have more than one primary actor in a use case?
Yeah.
Why do you say yes?
But if it was like rumor, then the driver would act with the system as much as the person wanting the lift.
Yeah, perfect. So what you're sort of saying there is that I can have more than one person, like one actor associated with the use case. And this example here, right, this actor or this person could be me. This is an actual person called a driver, but there's an important distinction here. So when it comes to use cases, there's always a goal of the use case, right? So I interact with the system, and the system sequence diagram will always have a goal implied, and that goal is associated with the primary actor. If I have more than one goal, it's two use cases, full stop. I'd never have two people interact with the system as two primary actors, but I will have secondary or supporting actors, which is what you're talking about. So I will have people that need to be involved in this flow to make it happen. And so the driver is an example, and the bank is an example as well.
So I think when we're drawing a diagram, have a situation where driver is on the left as a primary actor for one use case.
Exactly. Yeah. And so when you draw that as your sequence diagram, you'd actually have to denote here. So here I would have
the, I don't know, user, or maybe a better name, everyone can be more creative, the booking person being here and they interact with the system. But then I might have like another use case where my primary actor is the driver, right? But it's shown as a different one. So, use case 3, and then this one here could be the driver, signs up or registers for Uber or something like that. But I denote it as 2 different people interacting with my system. And so then they'd have 2 separate sequence diagrams and they'd both be their own primary actor in their own sequence diagrams. All good? Yeah, awesome. Okay, so I'm going to come back to design sequence or just sequence diagrams once we jump into solution space. So I don't want to cover that now. But what I sort of want you to know, or what you'll see, is there's very similar, like the similarities between the problem space and the system sequence diagram, very similar to the solution space and design sequence diagram with some key differences. And that's sort of why I'm doing all of this, to get those differences clear in your mind, because that's easily like maybe one of the more confusing things. Okay, what shall we do next? Maybe domain models. Where does this belong? Yep, someone shout out. Problem, solution, problem. Yeah, perfect. So, and you'll notice a very similar flavor. In the same way that we had system sequence diagrams, which was about how, your system is black box, your domain models is very similar to that, right? And then there's also a counterparty here, which is what's going to be my counterparty for domain model? Design models, perfect. So we had it here. Let me just shift all of this. Okay, so do you want me to spend time talking about these? I'm guessing like it's a pretty big part of what we do in this course. Yeah, okay. So quickly tell me, what is appropriate terminology in the domain? What's appropriate terminology in design? And again, hint, it relates to problem and solution space. So let me ask you a question. If I have something like a database that I'm designing, does that make sense in my domain? No, right? It makes sense here, absolutely, big green tick, but does not make sense in the domain, right? It's not an entity or it's not something. So domain models is all about trying to represent the real world. That's the whole point of it, and it's very high level because of that. So it could be a little bit obscure, like a little obfuscated or whatever that, but it's all about representing real world. And so when I talk about an entity in my domain model or something in my domain model, it represents something in the real world. Does that make sense? So if I talk about a glass, I'm talking about a glass in the real world. Or, I think you spent some time looking at the LMS system, exactly the same thing. Lecturers, students, physical lecturers, physical students, their physical relationships. And so domain models is all about grabbing those interactions and showing them at a level of detail. And you'll notice that this here is very dependent on time. So I can read this diagram and I can go downwards, right? And I know the first thing they do is try and book a ride. Then they would book, they try and then they book. When I look at a domain model, it's the static version of that, right? It will map out like my actor, and it will map out my bank, and it will map out my driver, but it doesn't tell me the sequence. But there's more detail. So it told me my actor will have, conceptually it makes sense for them to have a name. It makes sense for them to have an age. I probably need their bank details. Which is a good question next. I know this syntax, so it shouldn't be capitals, it should just all be lowercase. And then can someone else tell me, it also shouldn't have these negatives, right? So that doesn't make sense because public-private is a solution space thing. It doesn't make sense to have the notion of public or private, just makes sense to be this. And so at a very high level, I would have this kind of entity called actor, and then this entity would have associated fields. One quick question for you. When I talk about the fields associated with an actor, is there a rule of thumb for how I know whether something like bank detail should be its own field or a separate entity? This is a trick question. No, not a trick question, but I'm trying to get your brains going. Anyone? Yeah? Yeah, that's a really close. What I was looking for, and maybe this is that you haven't heard before, but if it's
So if the fields themselves are strings or numbers, so like letters and numbers, it makes sense to be its own thing. If it's more complicated, it should be its own entity. It's just a rule of thumb. Like in the exam, if you put bank details separately or you put bank details here, you can argue it both ways. But in this case, because bank details has information like the actual bank number, who you bank with, your address will have to be in there. There's a lot of other stuff that goes on. You can argue and you should pull it out. And the rule of thumb exists. Like, I know I'm not here to teach you the course, but the rule of thumb exists because when you jump from domain to design, implementation details become a lot clearer when you model it correctly. And so we use this rule of thumb, and you can kind of imagine why. If I try and implement bank details as something inside an actor, that is going to get really complicated really quickly. Pull it out, rule of thumb, it'll just make it easier. And so that's why the rule of thumb exists. But you're right. So there's this, how complicated this notion is. And what you were saying about having associated like methods and stuff would be very similar. So just wanted to call it out. You can do it either way, and then they have a relationship, right? And so someone quickly tell me what's important with this. I'm in problem space, so domain models. There's a very restrictive set of links here. So I'm looking for some details. Is it appropriate to have text? Yeah, right. So I could put has a bank account. That makes sense. It doesn't have to be underscore has. Like it doesn't have to be as formal as has a, right? That again, with this underscore or whatever, or capital A, it's a bit too formal. We're still in problem space. We're just trying to describe the relationships. So having words and spaces is fine. And then is there anything else? Yeah. Yeah, multiplicities. And so you just have to choose something that's makes sense. So bank details will only ever belong to one person. I think that makes sense. An actor could have 0 or many bank details, right? Like maybe you sign up on the system and you have 0, or you have to sign up and you have 1, in which case it would have 1. So it just depends on the question. Any questions so far? Yep.
So we talked about these sort of concepts come from the domains, so like the prompt that we're reading, whatever produced by business, I guess. To what extent can we like infer stuff? Because I think like, for example, there's the LMS doing the tutorial where like a lot of stuff was inferred, like the subject.
Yeah. It's a great question. So what we'll actually cover next is when I come to infer stuff, there's a difference between mapping it out in this problem space. So the goal here is to just describe the problem. And you're trying to describe it to the best of your ability. So you'll get given a piece of text and you look at that text and it will say student, it will say class, it will say things like noun extraction is a way to get there. So you just pull out what's written, but then when it actually comes to implement it, then you start making stuff up. And I'm jumping ahead a little bit, but you hear this thing and we can talk about it when we get there. But there's a design pattern called pure fabrication, which is exactly this, making stuff up to make it easier, right? So, but this belongs in solution space. So we're not quite there yet, but we can talk about it. You can use pure fabrication and you just make stuff up, is what that's about. But we're still in problem space. So here we're just capturing what's written on the piece of paper, nothing more. Does that answer the question?
Sort of, but also, did they have Tony's pizza back when you were?
Yeah.
Yeah. So in the Tony's pizza example, I remember they had these like style description classes that showed up in the domain.
Yeah.
You know, it's like pizza style.
Yeah. So, like, I think like we can go into details offline. But what I just want to call out, so I mentioned before, there's this notion of more complicated than plain text. You pull it out as a separate entity. So this rule of thumb that I've just mentioned here is exactly what happened in Tony's Pizza. And the reason it was there is to show you this. So in Tony's Pizza, you had a pizza and you had something that was more complicated than plain text in the actual domain. And so you pulled it out as a separate entity. They were following this rule of thumb.
I think to add on to that, because like the whole idea, as Rob mentioned, that when we're in this problem space, is we're truly trying to nail down, I guess, those requirements, I guess. in this domain models, we're trying to model the best we can, how we can represent different entities, different models, whatever, into those little boxes as we can. And then as soon as you start hitting hurdles and being like, I don't know, where the text does not mention subject anywhere, that's where you would raise a question. Let's say you own a project, a software project, and you're trying to start on this, you're on the slightly more business side of things, and you're trying to nail these requirements down. That will be where you would start to question people, be like, do we need the concept of the subject? And you start asking questions, and then if the answer is yes, exactly, that's where you decide to put it in. And I guess your question about Tony's Pizza in terms of, I guess, do we need style description? I mean, that's the very first step in terms of, I guess, solving that technical challenge. How do we actually go about modeling those different styles that we have? You probably think of every person will probably think of a different way to go about solving that challenge. The style description in terms of that is one way that we could go about it. Using bank details as a separate entity. The problem answers there could be endless. And it's just the domain model is the very first step to go about addressing those problems. And then we address it even further when we go down into the solution test.
Okay, and just one quick one. So there was a question on chat about methods and these entities that we've got here. So is it appropriate for something to have a method if it's a domain model? No, right? Like that's description of how you would implement it. It's not a description of what it does. And so then this relationship here, this wording, all it is it's just trying to capture the real life relationship between two things. It's not describing it has there will be a bank account or how many. It's not a method that we'll call. It's just an attempt to describe the relationship. Yep.
If you have two concepts that have two different relationships, so you have two different lines.
Two different lines. Excellent question. So we're getting a little into the trickier side, but so let's say an actor has a bank account and a bank account might be owned by, right? There's something here. Does it make sense to have this? Is essentially what you're asking. No. So I think I say no very wholeheartedly. We can get into that. You probably redesign this to not have this two-way. And so I'd probably be looking at pure, trying to make up a separate thing and have a three-way rather than just two different relationships here. But you're not going to get asked this on the exam. So I don't want to spend too much time on that because it can get a bit tricky. But generally speaking, you just want clean connections like this. Okay. Any questions? So one more thing here. Does it make sense to have something like an arrow as a connection between these two? So if I had an arrow, does this make sense instead of a line? No. And the reason why is because we're just at a very high level. So the only thing that exists is a regular line or this thing which we call inheritance. So, I mean, I know I'm talking a lot, but bear with me, it'll all come together. So something like this, or did I draw it wrong? Is it like this? No, I drew that right. Did I? Someone confirm? Oh, sorry. Okay, so there's this kind of relationship, and what does this mean? Yeah.
Like generalization, specialization.
Perfect. So the terminology there that was used is generalization and specialization, which is exactly what I was looking for. So I know the same symbol exists when we jump across the problem space, and it means inheritance. But in solution space, it just means generalization. And it means that the thing on the top is a more generic thing than the thing on the bottom. So here it makes sense to have a person and then a student. Student's more specific than a person, but there's this relationship. When I code that up, I would code it up using inheritance, right? And very conveniently, the same symbol exists because it's the same kind of relationship, and we capture that in code in a very similar way. But these two things are the only things that should be here when you do a domain model. Yeah? Okay. Awesome. So where did my little list go? I'm looking at time, so at 3:40, I think let's do this for another 20 minutes. Is that okay with everyone? And then we'll try to get through the content, and then we can deep dive into some stuff, or we can jump into exams. That's okay? Yeah? Okay. So let's pick the next thing. Maybe I'll just touch on these: system communication and communication. Secondary material, it's just aimed to be a more description version of both of these. So if you have a look at the system communication or communication diagrams, they'll look a little bit like this. Right, so I would have the same, like a very similar thing, customer system being a black box driver and payment. The only difference is that there's flows of information shown. We won't go into detail. You might be asked to draw one. Just know how to draw it. It follows exactly the same rules that we had before, right? Black boxes, people, high level stuff. It's all pretty similar. Okay. So I don't think we need to spend too much time on that. And then let's quickly touch. So here we go. What's technical memo? Where does this belong? It's a bit of a trick question, but so I'm going to put it down here as architectural analysis, unified process, and technical memos. They all are about the actual solution or the implementation, but it's also a little bit more high level, right? We're not coding anything, but we kind of understand these design patterns. We talk about design decisions that we made. We have to write some text to justify. All of that kind of stuff belongs together, but it's not directly related to UML, for example. So we can touch on those. And then the last ones that we've got here is probably getting into the more interesting side of things. So let's quickly jump across to solution space. Okay, so I mentioned before, we've got the system sequence diagram, and here we've got a design sequence diagram. What's an appropriate level of detail for a design sequence diagram? Am I talking about methods in classes now and implementation detail? I am. So what we expect is that when I do something similar like this, like let's say I was talking through how I would do my sequence diagram of the actual system, it's going to look a little bit different, right? Having an actor is not appropriate, right? Because that's the actual user interacting. So that's going to be gone. And instead, how am I going to start my sequence diagram? There's a very specific thing here that's like convention. A black dot. Yeah, exactly. So instead, what I'm going to have is a little black dot. Let me get that. And this here is to indicate the start of my call, right? And the whole reason for this is my system is no longer just a black box. My system is going to be methods or like class names, and there'll be methods on those classes that I'm calling. So it's going to be more detailed, right? And here, maybe I will have a call. So a user handler, right? And maybe I call this, it's not going to be try book ride. It's going to be try book ride, right? It's an actual method that I'm calling. Where this method starts, a black box because I don't care, right? This could be a user. In reality, the user probably has like a front end and they poke a button and the button has a callback or whatever. You're talking about how your system works. And so you just call it a black dot. Something happens and they call this function. How you get here, don't care. But once you get here and you call this function, then this is exactly what's happening. So my user handler might then call my database, or whatever. I'm doing this on the fly, so it's probably a little bit bad, but this could be like try book handler, and then this could be, like record attempt or something, So then this will be a method that's on my database object, and then when I call that, something else will happen. But you map these kind of interactions out fully, you've got a black dot, and then you don't have this. But I might have like a driver class. Let me just, which then represents my actual driver. Something like that. Yep. Yeah, yeah.
How does that work with creating the objects? Do you just like I mentioned it to my tutor and they were like, you can just say create, but that doesn't seem very aligned with.
No, so that's actually a really good question. And you are not jumping ahead, but that's what we're here to talk about. So there's some syntax that exists. I'm just going to paste it in here. What you're talking about here is class creation. So when it comes to object creation in UML, this is what the syntax looks like, right? So class 1, which is an instance here, it has a lifespan, which is this line here. It will then call something, but instead of calling an existing class, right, it then calls into that class and creates it, which is why this create and the class is down below. So that's that exact terminology that you just said. Yep. Onto this. Oh, yeah, sure. So we can also like show this Excalibur after. So if everyone just wants copies. Other than that, like Charlie and I also have like a pretty good record of this sort of stuff. So I'm sure we can share that with you, but this is what it would look like. And so what you said before about class creation, there's actually a very similar syntax for destroy, right? And that syntax looks like this. And then when it comes to doing complicated things within these loops, you can have this thing called frames and you have a condition, right? So you can have a loop and a for each, an option and whatever, or an alternate. And then within this alternate, you'd show different paths. But the intention being that you kind of have this unified language. And then within that unified language, when I talk about my sequence diagram, I'm showing all of the function calls I'm making, right? So I can look at this and I can tell exactly what your code should look like because you're implementing your code off this. I don't know what is happening inside each method, but I know what methods you'll have, what they're calling, and the interaction between your objects. That's the whole point of this. Okay, and then maybe I'll just drop this in here as well. So this is the other side of that. I said before, like UML particularly can be a little bit varied. When we're in the solution space, the UML gets a little clearer, right? So here, people actually have more set definitions than when we describe the problem space. And so that's what this is, right? So ... sale, unnamed instance, S1 is a named instance, this is a blah, this is a blah. Like you can maybe read this in your own time, but then this would be like a very high level, right? So black dot, you do something to class, this is the length that that method is activated. There's another method here called clear, there's another method called do B, do C, etc. And this one here is an example of do C calls do B, and you can see that's defined there. So all of that exists. And you can use that level of detail. For the exam, don't worry too much about this, right? If you give me this, I'll be happy, right? We're looking for you understanding the subject, not knowing the details of UML, unless it's changed. So that's probably the disclosure at the start. Okay, awesome. Let's quickly move on. So any questions around system sequence diagrams or where? Okay, yep.
Like what the little like pipes are, like how long should they go for?
These pipes here. So these pipes is a representation for how long the method is active. So in this particular example, right, I might have a try book call writer, and I can see here that the method returns at price. So my method is only going to be active or it's going to be calling for this duration. So the only thing that happens is, let me just get rid of that. The only thing that happens here is there's a call to record attempt. If there's a new call here called book ride, then this will be active for this long, right? So, and then inform, but then maybe something else happens. And so it could return down the bottom here. And this is also what I was saying before with the syntax. So we can have two different ways to represent this. One could be my price is equal to try writer, right? And then I don't have this return. If I do that, I have no idea how long this method is active, right? It suddenly becomes very unclear. It could be the whole thing. It could return at the end. It could return at the start. And so that's why I personally recommend doing this because it's a lot clearer. And you can see that it's only active for that long. But if you do either, it's fine, right? They're both accepted. If it's a small method like this record attempt, it's probably not worthwhile doing 2 arrows. If it's a longer method like this one or this one, it's probably worthwhile doing the 2 arrows. Just small stuff. All right, any questions here? Yep, we've got one.
We've been dealing with things like databases and stuff, like that's kind of.
Yeah, so like we're gonna jump in. So when I say database here, what am I talking about? Or specifically, okay, let's talk this. What's user handler? But I'm gonna implement it in code using Java, so it's gonna be a class, right? So then this here, is it going to be a class or a database? It's going to be a class. So what this implementation probably does is hook into a database and it wraps my database, and we'll talk about design patterns, how you do that, right? Like adapter is exactly one. But this terminology here, when I say database, I'm talking about a class that implements database. It gets a bit confusing, but you do it like this. What it does, you're right, it probably calls in and saves to an actual database, but that'll have to be a separate one. So in this particular syntax, I'm just talking about a class that I create. And why I would want to wrap my database like this is to try and keep these things nice, right? So we're talking about design philosophies and Gang of 4. You can come up with a lot of reasons why wrapping your database in a separate class is a good idea. And we can talk there when we get there, but it is a good idea, for a whole bunch of reasons. Okay. Awesome. So let's quickly, move on. I think let's talk about the class diagrams, which we said before. So we've talked about domain and sort of high level, jump across the class, we're getting more specific, right? So if I have my domain model and I look at my class diagram, which is here, static design models. Oh yeah, one thing to call out, when I say class, I mean static design models. It's the same name meaning different things. Unfortunately, it's just the way that this sort of UML is not precise. There's a few different names for these things. And so I call it a class, design diagram, diagram, or you can also just call it a design model, I think. All of it is the same thing. Okay, awesome. So when it comes to this more specific, we're getting more specific, right? So I might have an actor that notionally makes sense. Now I'm going to start talking about the detailed implementation of this actor. And things like variables become important. This name is going to have to be a variable. Its type will have to be defined. If it's public or private, will be defined. If I need methods to support interactions, they'll have to be defined. Everything here gets more defined, right? So at a very high level, you can kind of think that, okay, I'm going to have an actor. My actor will have a private type called name that's going to be of type string. Is that the right representation? Is that what you are used to? Yeah. Okay, cool. I was just double checking. And then I'm going to have like another private variable called age. And this might be, you know, an integer or whatever it is. And then bank details is going to be something else. But let's quickly talk about that because that's quite important. So here, if I have bank details and just pretend like you know what those are and all of those details are specified, would I have a private variable called bank details of type bank details? Here. No, right? And I don't do it because its existence is implied by a connection. So just want to get that clear. We don't show it, but when we code it up, we know it has to be there because there's a relationship between actor and bank details, and I'm in the solution space. So I'm not describing the problem, I'm describing the solution. And I show here that bank details exists, and it's going to be a one or many, right? And I know how to implement a many, or I know how to implement a one. I'm going to use like arrays or single variable instances or whatever, but the fact that this is a star on this side means that it has to be represented as an array list or a list or something inside actor, right? So its existence is implied because there's a line here. Okay, so let's just quickly talk about the different kinds of lines because I think that's like a very common confusing thing. And I'm running out of space. Okay, so UML notation, we said before, in the problem space, it's very specific. I have two kinds and that's it. In my solution space, I have a lot more because I'm getting more into how I implement this stuff. And in particular, I've got these kinds. So I have an arrow or a line. Quickly tell me the difference between a line and an arrow. Yeah.
The lines of things on either side have each other, whereas the arrows one-way.
Exactly, yeah. So this arrow here implies that it's a one-way connection. So the object on the left knows about the object on the right, but the right does not know about the left. And that's exactly the same as saying on one side, I would have a 0, and on the other side, I would have a many, right? So instead of writing a 0, we just put an arrow. So it's very similar. You could do either. We're not going to penalize you. But that's the difference. So when I draw an arrow here, I'm also talking about a line, right? Like they both mean the same thing. They mean there's an association, which means the two classes will have variables pointing to each other, however that looks like. Okay, then we've spoken about inheritance and we know how to code up inheritance, right? So that makes sense to us. Implementation realization. So this one here with the dotted, what does this mean? Interface, exactly. So I'm going to have some sort of level of abstraction and we can talk about when we get that to gang of 4. But then I'm going to be implementing that method and I show that by using this dotted. Okay, awesome. The next two, composition aggregation. This is by far the most confusing thing I think we talk about with arrows. And so does anyone understand it? Yeah, perfect. Do you want to have a go?
Okay.
One of them implies the existence of a larger parent object, necessarily implies the existence of component objects, whereas the other one is there's a larger parent object that can be comprised of some number of.
Yeah, okay, so I think that's a really good attempt. It's correct. That wording gets confusing, and it's confusing because it is. There's this relationship here, this aggregation composition. It starts trying to describe creation logic, right? So we saw before in a UML, like when I come here, there's this notion of create, where a class creates another. That level of creation gets implied by aggregation composition. And my question to you is, should it be there, right? Like my personal advice in the exams, don't use it. It gets overused all the time. There's a whole design philosophy around creation of objects, which we'll talk about gang of 4 creation design patterns, right? All of that exists to solve this problem. And so drawing it as a composition or aggregation is probably a little bit overkill. Does it have to be there? No. Is it there? Yes, it's probably there because people don't really understand it and they put it in. Just skip it is my honest advice for the exam. Unless you really want one to create the other, then the difference is composition versus aggregation is who destroys that object. So we've shown here before, class 1 destroys class 2, right? So this class is responsible for creation and destroying. That is a composition thing, right? Like if I destroy the parent class, the other one needs to go. And the example here would be like, I'm modeling a dog and a dog has legs. If I destroy my dog, it doesn't make sense to have just legs in my code. It's confusing, right? So we can brush over this. The other one is like, it does make sense. So if I have a pond and a duck and I create a duck in my code and then someone comes with a bulldozer and destroys my pond, it makes sense the duck is still alive. And so that's the difference between these two, but they're talking about creation logic. But we have design patterns for this. So try not to use them unless you really know what you're doing, is my personal advice. And in which case you should probably look at design patterns for creation logic, because creation logic gets complicated. And so you want to be using a design pattern. Okay, awesome. Any questions around this? Or am I like tiring everyone out now? There's a lot of content, so I do apologize, and we can also take a break. No? Okay, cool. So maybe let's quickly try and finish this because we're getting closer. Let's talk, what do we have left? So communication, let's quickly touch state machines. I think here, like state machines, you probably did some for your assignment, I would imagine. Like you had to draw a state machine and you probably had like a notion of a sub state machine. Okay, so I'm just gonna drop some knowledge on you and then we can talk about it and we can move on. But this would probably be like a more complicated version of a state machine. So you always have a black dot, which is a starting point. This black dot, am I in solution space or code or problem space? Solution space, right? A black dot, it's actual code, it's what I'm implementing. And then I would have triggers. This initialize is probably standard. So I always start my state machine and go into a certain state. And then there's some syntax here. So trigger is like the thing that I'm going for. The guard is a condition. So if I want to do it or not, and then the action is what happens. So you can kind of see how you mock this is like maybe if daytime I flicker, if nighttime I stay on. I might have sub-state machines. So one thing that's important is when I transition states from an external to an internal, I just go into the state. I don't necessarily go into a given state inside, but I go to the state machine and the state machine will have a start point, right? So there's some syntax here. I think you should just revise yourselves on the syntax and then be comfortable drawing simple state machines. You can pull out states from text. The transitions themselves, you can model them whatever makes sense, but just try and keep it clear. Right? Like in the exams, we'll be looking for like, okay, it makes sense. There's probably only one way to model it in an exam, so try not to overcomplicate it. But you'll probably get asked one with a sub-state machine as well. So just make sure you're confident on that. I hope. I don't know if you're getting state machines. I didn't have anything to do with it. Okay, any questions here? It's a very rough diagram, but yeah.
About the guard, is that something that, so the trigger is a thing that can happen?
Yeah.
The guard, if the guard is false, even if the trigger happens in one.
Exactly, yeah. And so you won't always see guards. Another way to put a guard is like this, right? So a decision point. It makes sense if my guard is a Boolean, like a yes and no. Doesn't make sense if my guard is, it has to be one of 5 conditions, right? Like that gets a bit hairy. And so a guard is not always seen. So you can see here, I stay on. I always go to off if no movement's detected. It's not like I go off after, 3 times loop or something, right? Like this guard would then add a condition saying that I have to loop 3 times before I go off. There's just an unconditional transition. So the guard is optional. Okay. Anything else? All right, so we're probably to the media sections here of software modeling and design, and that's graph gang of 4 design patterns. So I'm probably going to need a lot more room, but we can talk about it here. Let me quickly start. So is everyone sort of familiar with what GRASP is and what gang of 4 is? We spent some time studying. What I really want to call out is just shout out what the GRASP principles are. So that's the starting point here. What are GRASP?
Pure fabrication.
Yeah, pure fabrication.
Creator.
Yep. Yep. Perfect. Yep. Yep.
Protected variation.
Yep. I don't want to type it all out, but I've got the list on the side. So I'm just going to paste it across once we have it. Okay, so we probably had something like this. Creator principle, information expert, pure fabrication, polymorphism, controller, indirection. And then the other 3 that I was looking for that I'm sure was said is also protected variation, low coupling, and high cohesion. And why I've pulled them out separately is for a very important reason. So when you get asked questions and you have to justify your designs, it is all about these 3, right? These 3 are like the pillar or the base of a good design, but they're also a trade-off, right? I can't have low coupling and high cohesion. It just doesn't exist. I can't have protected variation with the others. So when we talk about a good design, we can justify it using these 3, and the others are really just there to help us, right? So polymorphism helps get you low coupling. Information expert helps get you high cohesion. Creator principle helps get you the other, but all of these together are my GRASP principles. And so you should be fairly comfortable with arguing why something is a good design, and you can tell me reasons why it's not. So we talked before about creator, right? I can come up with reasons why having that aggregation or composition is not a good design, right? And I can tell you because it's not high cohesion, or it's, and we can argue that, right? Creation is separate, logic should be separated, or it's not protected variation. I extend it, how on earth do I create new instances? So you've got these design principles, and they're like reasons for arguing for a good design. When that comes in handy is when I start talking about design patterns. And design patterns are like the universally accepted way to do stuff, right? Like software engineering, we've been doing it for a while now. Everyone comes across the same points. And so we have the shared language of how to optimize for this. And I can tell you that even if you don't think a design pattern is a good idea, it is a good idea. And it just means you haven't thought about reasons why. And we can talk about that, but like in real life, code gets very complicated. Like I know we've been doing small projects and things make sense and they're never going to change. In real life, they're always going to change. And so putting in design patterns when you implement stuff in real life caters for a year down the time when you have to do something else. And if you don't do it, you'll be kicking yourself in a year's time, or someone else will be kicking you. And so this course is really about turning you into good software engineers, which is why we spent so much time talking about the reasons why and how you can argue about a good design, and then also what a good design could look like. Okay, talking a lot. Are there any questions on that? Or do you want me to, I'll quickly go over the design patterns. I'm not just leaving it there, but any questions about GRASP? Yep.
What controller?
Yeah, perfect. So controller is a really common one. It's not to be confused with the design pattern that is also controller, I believe. But controller is all about, strictly speaking, your UI interactions with your system, right? So the system doesn't happen. There will be UI stuff, right? Like think of a front-end web page or something. Controller is a principle to deal with user interactions. That's what it's about. And it's there to help you differentiate what happens at the user level to what happens at your system level. And that's what it's for. And that's why it's there to argue why you should have that. And like when you start talking about it, it makes sense to separate control logic out or separate the actual callback handlers or how users interact with your system into a class that then controls your system. And so it's called controller because it'll pull the strings internally. Like let's quickly go to our example here of a user handler, right? Like you can argue, you could probably have all of this in one class just called Uber, you know, and tell me reasons why this is terrible. I can tell you using gang of four patterns, but then I can say, using controller, I should probably have something here that calls or handles my user interactions. And so by the controller, you know, pattern or like the graph principle, it makes sense to have this and then makes sense to have this interact with Uber, and then the user interact with this. And so it's about separating this user interaction away from the rest of your system. That's what controller is. But it's not about controlling your system. A very common mistake. Does that make sense? So controlling your system is like who should talk to the database and when, what happens when I read a record from the database, what happens when I call a third party and why. All of that is internal to the system. It's not, it's about when my user presses this button, then these things should happen.
UI player, whatever that is, doesn't know about any of the classes in our little system.
And should it? Tell me why it should or shouldn't. That's the grasp principle. So you'd argue, right, like you want abstraction and you want to keep protected variation. You don't want like a UI layer to reach into your system and do stuff. You want to separate those two and have a very distinct layer between. And so, no, it shouldn't, right? You want to abstract it away. You want to have something that the UI talks to. And there's a principle all around this because it's such a common problem. Okay, any other questions? Cool. So now let's quickly dive into our design patterns. How much time? So 4:10. I'm conscious I'm talking this whole time. You're happy to keep going? We talk? Yeah? Okay. So do you want me to talk about each design pattern or should we quickly just call out what they are and then touch base on the ones that you find the most confusing? Yeah? Okay. So what are the design patterns? Yep. Strategy. Yep. There's quite a few. Maybe what I'll do, and just to help solidify, I'm going to pull out these three. So I realize maybe the course content didn't break them down like this, but they relate to three different kinds of behavior in your actual implementation. So one is behavioral, so what actually happens. The other is structural, how I structure my code. The other is creational, which we talked about before. So aggregation, composition, who creates what object. You can tell me why it's a bad idea to have creational logic splattered throughout your code because you'll never figure out what's going on. And so design patterns are all about solving specific problems, right? And we group these problems into behavior, structural, creational. But what's really, really important and what I can't emphasize enough is I use a design pattern when I have that problem. Full stop. If I don't have that problem, I don't use the design pattern. So if you get a question in the exam, it will have a problem and that will have a design pattern. There's only one pattern, like there's only one problem, one solution. It's not going to be you can use multiple patterns, right? So just make sure you understand the actual problem these design patterns are solving and then how they solve them. But step one is identification of the problem, right? And the problems can be grouped into different things. And then where it gets a little bit trickier is you might have multiple problems, right? So let's take, for example, we see this before, but a singleton factory, you know, the singleton thing is addressing a universal access to one instance of my class. That's the problem that it's solving. That's how I solve it. Factory is addressing complex creation logic. Separate problem, how I solve it, right? So you can combine these design patterns together, but you're solving two problems, both of which you just happen to have. And that becomes quite common. So I get that it gets confusing there, but just make sure you're very clear on what the problems are and then the suitable solution. Yeah? Okay, so I'm just, for lack of timing, I'm just going to drop this in here, which is the patterns. Let me know if I've missed any, because I think like sometimes they change a little bit. But under behavioral, we've got observer. Everyone understand the observer design pattern and what the problem it solves? Yeah? Okay, then we've got strategy. Everyone understand the strategy pattern and what problem it solves? Yeah? Sorry? Oh, yeah, of course, sorry. Okay, maybe we can do that. So behavioral observer, right? This is probably pub sub. I want anonymous notifications, all that kind of stuff. Very common problem, very nice solution. Strategy, again, is very nice. I need this particular thing. And what I'm talking about is strategies internal in my code. So one question here, everyone knows the adapter pattern? The adapter? Yeah, so why, like, and this is something we see, is strategy versus adapter gets mixed up a lot. Right, so adapter solves a different problem than strategy. Strategy is all about how your code behaves. So you implement it, you write the code yourself, everything is within your control, so you want different strategies. And the classic example here is sorting algorithms, right? I write different sorting algorithms, I want to hop swap them, or I might want to put one in and not the other. Okay, and then you've got template, which again is a very similar behavioral pattern. Okay, so then structural, let's quickly maybe skip decorator and composite. These two always get mixed up. Facade is all about creating like a broad set of objects. I abstract that away. The internal logic I hide, the problem that you're solving. Adapter, I'll spend a little bit of time because we see this, is all about controlling access to external stuff, right? So someone has written some code that you can't change and you need to bring that into your system. That's the problem adapter solves. So there's maybe a database, right? Like you didn't write the database, you don't have control of it. There might be a third-party API. You have to use what's given. It's not, I want a different strategy, right? These two solve different problems. An adapter is always connected to something external, right? If it's connected to something like a method that you wrote, you're using the pattern incorrectly. It's all about controlling external stuff into your system. Okay, so then let's quickly talk about decorator and composite. Anyone understand the differences between these two, different problems that they solve? So this one here is like, is super common. Calling out decorator, specifically right here, it's all about dynamically. So at runtime, my code is running. I want to do stuff on the fly when the JVM is going. That's the problem decorator solves. And what this might look like is I create an object, maybe I want to do something. So classic example might be encryption. You know, like I save it to the database. On the fly, I want to encrypt it and then save it. Or maybe then I want to encrypt and then compress and then save. All of that kind of stuff is what you would do with decorator when you have that problem. Composite is when you're trying to create. So this one here is, it only makes sense if you've got like a tree structure. So that's like, I know we're rushing through explanations, but here it makes sense when I have like this kind of tree and I don't quite know what it looks like, but I want to be able to structure a tree and pass it around. And I don't want other classes to know that I've created a tree, right? From their perspective, it's just one single class, one nice method all wrapped up. From my perspective, I have this really cool implementation where I have nodes and leaves and internal leaves, and it can be as recursive as I want. But from the perspective of whoever's using me, it's just one single nice object. So you're creating, or like you have like a very complex composition, which is why it's called a composite. Here, I'm doing stuff at runtime, so I'm decorating the behavior. Any questions so far? Yep. Yeah, perfect. So a strategy is when you want to swap it out to do, and this actually, like, we go into the nitty gritties, but let's quickly, okay. So let's take this example. So when I come in here and I call let's quickly talk decorator. So decorator, you can think of as going to be like a recursive thing. So I've got a top level object. This top level object might do something, but then it's going to call into my sub level object. And what's important here is that this sub level will exist. So you kind of wrap these things on your implementation and you'll have function calls down a tree, right? So at the root, my call could be like save to the DB. Oh, wow, that happened. So save to the DB. And then what I do with that is maybe then if it's like maybe I have to encrypt it or maybe I have to compress it. And so then these top level calls will be compressed. But what's important is I would then create this modification and pass it down within this like decorated object that I have. So you've got this recursive behavior in decorator, all internal to the actual implementation that you're talking about. So you might have different classes, but it's all within this decorator pattern. Then when it comes to also remember two different problems. So this is how you structure your thing. When it comes to strategy, you have different things you want to execute. So I might have different strategies, and it's all about hot swapping or doing these strategies differently. So, and I call strategy because the pattern's called strategy, but it's like, so sorting is a classic example, right? I want in my application, I want to be able to call .sort on a method. But then, you know, like maybe when I'm starting, I don't care about timing, so I'll just go linear sort, right? And then once my data gets more and more, I then have to optimize. And so you use this decorator pattern to then suddenly swap out your implementation of sort to something else, right? And so then you might go bubble sort, or you might go something else. It's not at runtime though. So you'd make a class modification and you would instantiate a linear sort or a bubble sort and pass it into this strategy. It's not like my code's not running and I don't dynamically decide what my sorting algorithm would be, but rather I create this like structure in my code where I can swap it out later down the track.
But isn't that still at runtime? Because like it's things that happen while it's running.
So decorator will be, a strategy won't necessarily be. So in my strategy, I could have my main method, right? And then I go my sort strategy, sort is equal to new bubble sort, right? That could be option one. And then I decide that. And then I come back a month later and I actually go, oh, let's do, you know, radix or whatever.
I think to add on here, I think the big difference in terms of like talking about decorating strategy here, like it is, you're correct in saying that they both allow for changes in behavior, whether there's going to be some sort of change, there could be if conditions, there could be some other factory class that, I don't know, assigns different behavior based on what you give it. But the important with the decorator is that there is some base behavior that you're decorating. There is some like the base thing that is this particular case, save to DB, that will always be the case.
Yeah.
But maybe in certain scenarios, not only do you want to save to DB, I also want to compress it at the same time while doing it. So that's why this has been classed as the structural side, because not only is it changing behavior, but it's doing so in a structural manner. So that, exactly. So it's kind of like that Russian doll analogy.
Yeah. And I think maybe I didn't emphasize it enough, but decorator will always execute a base case, right? So the same behavior will always happen. Strategies, you swap out what that behavior is. Yeah. Okay. And then we've just got our last two, builder and singleton. And do you guys learn factory? Is that supposed to be here or you did that? Yeah, okay. I must have missed it. But all of these is all about creation of objects. And you can very easily see why that might become a thing. Like what happens if I have a class that has potentially like 100 internal variables or 50 names? If I'm trying to create that all the time, I either end up with 50 constructors or I come up with a better way. And what do you know? There's a better way. So builder is about complex creation of a single object. So what I just said, 50 internal variables, sometimes you want to set them, sometimes you don't. Builder solves that problem and it solves it very nicely. Factory is about complex object creation. So I might have a very classic example, different strategies or different decorators, and I need to manage what I'm creating when. So this complex creation logic across like different classes, or maybe I'm trying to make a decision based on the type of class or a variable passed in, that's what factory is for, but it creates different kinds of objects. Builder just is the same object in different ways. Factory is different kinds of objects, but it could all be to an interface or something else. And then singleton is exactly one semantics. Do we need to talk about these anymore? Yeah.
I don't quite get builder in terms of.
Yeah, perfect. So builder is actually like a pretty nice, easy one to explain. So let's say I have name, number, phone number, right? And all of these in my class are optional. How do I create this without using design patterns? Well, step one is I'm going to have 4 different kinds of constructors, right? So a constructor that takes in name, number, and phone. And then I'm probably going to have one that takes in name and number. And then probably one that just takes in name. You can see where I'm going. And then another one that takes in number. So if I have 3 optional variables, I'm going to have to create a whole bunch of constructors to cater for every single scenario. And this very hurriedly can get out of control. So if I suddenly add in a fourth one, it's going to blow up, add a fifth one, then I'm going to start calling you a bit crazy because that's a lot of constructors. So builder pattern solves this problem by creating a way that you can set or optionally set some of these or not set them, right? And the behavior is defined. So then I can go, you know, I'd use it like I'd create a new builder, and then I would go, you know, dot set name, and then I would go build, and this would be valid. Or I would go new builder, and maybe this time I need name and number, right? And this would be valid, and then I build it. Ah, yes, set name, set number. So this kind of gives you a way to implement this class in a nicer way, but you do it because there's complex logic inside the class, right? So, yeah.
Don't we just go from having constructor for each case data builder class for each case?
But not each, right? So there's only one method called set name, one set number. If I don't call the method, it gets set to null. So here you just have one builder and you have four available methods or three available methods, and whether you use them or not is up to you. It's not like you then have to go and create a new constructor. So if I add in a new one, like let's say I add in what's suitable here, like address, right? All I have to do is implement set address, and then suddenly both of these are fine, and I just come set address if I want to add in an address. You know, and so managing that change becomes easier, but it's all on the same object, right? I'm building the same thing. Yep. Yep, so you're sort of jumping into, like, there's an option here of where by default I say is equal to null, all right? And then I take in a constructor and I override these things. We can talk a little bit about it, but one important thing, and I think the right answer here is, so these design patterns, we've been learning to code in Java, right? So very specific to that semantics. These design patterns are language agnostic. So I can use the same pattern in C, I can use it in Java, I can use it in Python, whatever, I'll always get the same benefits. Where then if I have to start dealing with setting number null, that's a very specific thing in Java. If I do this in C, that's not an option, right? So you'd use the builder pattern to address that. Yeah. I know that's probably not the answer you want, but, and that's why we try and stick to them. Yep. Yeah, so the good question, why can't I just have setters and then I would instantiate them all to null and then I would set them? A couple of reasons, depending on how complex this object is. Like, I know we haven't really talked about this too much, but let's quickly, so I want to pull up a real life example of when we use these things, right? And we start integrating with third parties. Like one thing that we would do at work is we use Kafka, which is like this message brokering system. And then it becomes really complicated in regards to what config you need for these brokers. And so there's a builder pattern that they've implemented that we use, and that's like very standard. If they went down the road of having just setters, it becomes very hard to figure out what you need to set. Because there's also logic that you can put in here to make sure your build is valid. So you don't enable them to create an object so that during compile time, you fail, right? Rather than during runtime, you haven't set a variable and then your program crashes. So you get all of like that other stuff. And so within the builder pattern, you can enforce that, okay, someone's using me, but they've instantiated enough for this to go ahead. Where with setters, you wouldn't be able to do that. Does that answer your question? We can talk about it more later as well. Okay, anything else? Awesome. So conscious of time, I know I've been talking a little bit. There's, what else do we have? Architectural analysis. I think here, maybe we can do the same thing. So let's just quickly, I'm just going to paste some stuff and then we can talk about it for 5 minutes and then maybe take a break. But when we come to architectural analysis, and there were some questions around this, just quickly want to call this out. So we've spent a lot of time in this application layer, right? And we talk about how to implement the application layer. We haven't necessarily talked about how to implement user interfaces or the interactions between. And so then architectural analysis and functional, non-functional requirements is all about the system as a whole, right? So when I say a system as a whole, I need all of this. We've been spending time just talking about the middle layer. And so I think what I would say for the exams, just know they exist, be able to spew one out. If someone asks you to write one, you'll probably get one. So just remember the format and then spew it out. What you actually put there is not so important, just knowing that it's there. In reality, they become very important because developers move on and things change. And so you want documentation, and it's really just trying to explain to you that's how things work. So just know they exist. Functional, non-functional requirements, this kind of stuff becomes really important, just be able to identify them. A rule of thumb, functional is what people tell you. Non-functional is like the ability stuff. So scalability, reliability, anything that you can kind of think of with ability or ility is a non-functional requirement, and they become very important. If you don't think about it when you do your implementation, you'll fall over, which is why we're calling it out here. So just know they exist, and usability, reliability, performance. Okay, that's not an ability, and then supportability, all that kind of stuff. Just be able to remember it, right? You'll get very high level questions. And then the IS logical architecture is very similar again. So just know it exists. We've talked about the application layer and domain, but you kind of have to be aware of all of this as like a software engineer. So it's just introducing you to the fact that these layers exist. And when you do real life applications, you operate and you just need to know where you sit. You have to know they're about. That's why they're there. So you might get very high level questions on this, but it's not going to be anything too detailed. Okay. I think that was it. Any questions? Or is everyone like minds blown? Sick of the exam already? Yeah, no, it's fair. There's a lot here. A lot of it is like a bit wishy-washy. Yep.
A little bit of a vision to, well, how important do you think it is for us to go back through all the charges, things like this?
Yeah, so maybe we can have two different answers here. I personally think like the exam, you'll get probably one of every kind. So one of this, let me just quickly go up. So, and I can tell you all this, just maybe don't repeat it outside of this room. But I think you'll get one sort of problem space question. So it could be draw a use case diagram, give me a use case, draw a sequence diagram, give me a domain model. I think you'll get one of these. You'll probably get a domain model or a design diagram because you spent a lot of time there. And then you'll get probably one of the more internal ones, and then you'll get a gang of 4 or something like that. So for the actual exam, be across being able to create each one of these at least at a high level. And hopefully by now you understand the differences in syntax, right? Stick figure should be there, stick figure should not be there. You'll probably get a question. The actual question itself will be fairly simple, right? It might have 2 or 3 entities, but you just be able to draw the relevant thing. And then you should know the design patterns, and you probably will get a design pattern question, right? So you'll be able to have to identify what the suitable design pattern is, and then show me, not the code, the solution, but show me what the UML looks like for the solution with the suitable variables. So, tell me, okay, maybe observer is a bit complicated. I think you'd be unlucky to get that, but like decorator or adapter, or even just a basic singleton factory, what are those variables? What are those methods? How do they interact? Be able to draw that. And
just to highlight another point about design pattern. You just mentioned that you may not necessarily be asked to implement, but it is also not out of the question for them to ask you to implement some things. It's probably, you probably will be on the unlucky side if they ask you to go about implementing maybe the observer design pattern, but it's definitely not out of the question. I believe there was one semester where one of the questions was actually to go about implementing, I think it was the strategy or the decorator design pattern, and it threw everyone out of whack because no one was expecting it. So it's definitely not out of question for these design patterns to get asked to go about implementing, but don't, I guess, if I were to take a sort of like a gamble on it, at least try and understand the more simpler ones, such as strategy or factory. Those ones are slightly on the simpler side, but if you were asked to implement it, then you can.
Then I'm assuming pseudocode would be fine, right? They don't expect full on Java.
yeah,
It's not full on, not full on Java. At least if you write out the pseudocode in terms of language agnostic and you can actually understand the concept behind it, then that's completely fine. Which is kind of follow on to my advice in terms of saying that for these design patterns, I would highly recommend regardless, doesn't matter what language you're using, just trying to get pseudocode down to actually write down and you actually understand how to use these decided matters in some particular way will be super useful for your exam revision or for the exam itself as well.
Yeah,
Will specific case studies be memorizing or will we be given context for the question?
you'll be given context.
It'll be given context,
Yeah,
pretty much.
I think and what the subject is about is not you memorizing case studies. It's about you being able to implement design patterns on a use case. And so you'll be given context, right? And you might have to do like noun extraction, come up with what your domain diagram would look like, or they'll tell you implement this. So it's more important to know how to implement these things. And when I say implement, I mean draw diagrams. Yeah, I don't think they'll ask case studies. Yeah. But it might be used for reference, right? So what's really hard and what's important with these kinds of exams is you have to know the context of what we're asking, right? Which is why there's questions about LMS, why you've been asked Tony Pizza and it's the same case study all the time. It's because you need to understand this domain to be able to model it. And so when it comes to writing an exam, they can't pick something that not everyone would understand because you might just miss the design because you don't understand the concept. And so they might reference like Tony's Pizza because it's assumed everyone has done that work, but they'll tell you what you need. And that's just to try and maintain context.
Just to emphasize as well, it hasn't already been said as well, I think it's really important to know, like it's definitely not out of the question for one of the exam questions to be like, hey, you're going to be given some context, maybe even some pseudocode to begin with, and they're going to be like, hey, in this particular scenario, what design pattern do you believe is suitable to solve this particular question that they've faced and they've properly explained the outcomes towards?
Yeah.
So definitely important. And I guess I know it's like definitely on the simpler side to read writing down what exactly each of these design patterns do, but it's really important to know these, what the purposes and how they work as well.
Yeah. Okay. Any other questions while we're here? Okay, silence is good, right? So I think we're happy we can deep dive into something if you want. We could spend some time going over exam style questions, or we can take a break and then decide and come back. So I think here, like, should we do a 5-minute break? Yeah, 5 minutes. And then we'll come back and maybe we can decide as a group whether you want to spend time talking about more content or go through some exam questions. Yeah? Okay. So I know we ran over time quite a lot. 4:35, so we'll come back at 4:40. Cool. Thank you.
You get the skeleton.
Yeah, well, so I'll just put a link to the slides. So I know we haven't used them at all, but there is a set of slides and I'll just stick the link in this recap. And then you can just hit the slides and follow the link. I'm trying to find water at work.
Yeah, I'll try to find the solutions.
Yeah. Yeah. Are you happy to run?
Yeah, I'm happy to run. Again, depends on what you want to do. Maybe I can give you.
Yeah, well, let's grab those. Everything down in that 30 minutes. Is that an actual exam question?
I don't know. The point is that it's really interesting.
No, I reckon that's not this question. I don't think they're gonna get sick.
That'll be back for the next time. Which is really. Yeah, this is. Yeah, it's got otherwise. We can go for it. The maybe we can actually go for this.
Yeah.
Maybe.
Oh, okay, this was a real one.
No, it's not. They're over which one.
Did you get maybe,
Oh, I didn't get it. Maybe that one?
I think I just picked one.
Which there's a cloud.
So we want to decide, and that's what talk about the changes you make. All four. Sound,
Yeah.
Hi there. I was wondering, if you can share the document you've been working on at the end?
yes.
You will?
I do,
Thanks.
yes, it might be a little bit of madness, but.
I'll understand it. Thank you.
I was able to explore this.
Yeah, I think there's, we can put a shareable link, sorry, and just try to implement it.
Yeah.
Keep for that email, me.
Yeah.
Oh, no, it's there, sorry.
I reckon it's just, have like a high level. Some of them?
Strategy.
Oh, that's actually that. That's exactly the give context.
Maybe it's on.
You don't have to decide outside.
smart today, I think. I'm sure it's smart today.
Yeah, I'm not playing.
I would love to say that.
Your screen sharing is.
I saw there was like a credit.
Yeah.
I didn't know.
I don't think so. Let me double check.
Maybe some shout out. Any questions? Making new posts and.
There's like, yeah, well, that's just cool.
Oh, yeah. This is a good one too. Your presentations. Questions. Fine.
Don't, I am not even looking. Yep, we'll get started.
I have.
All right, shall we get started again? Okay, so I'm being wary of time constraints, and we've only got around less than 20 minutes left to go through the rest of the questions. We've sort of handpicked a couple questions from a sample exam that we've gotten access to, and we just want to hear everyone's thoughts in terms of which question we want to go down to. So we've got two questions here. This one that we see up on screen right now, which we'll be talking through, I guess, what's some of the questions that you go through, exactly this, which is based on grasp. So you could think of things such as coupling, cohesion, protective variation. Think of all those things, keeping in mind what's wrong and how potentially we could improve upon this existing system. So we were going through that, talking through how we could potentially go through that. Or on the alternative side, there is another question further down where it's more so talking about design patterns. This question is more so asking questions about, hey, here's some existing code. First of all, what design pattern is this particular thing using? So that's the first question will be identifying what exactly that design pattern is. And on top of that, not only talking about what exactly that design pattern is, we'll maybe attempt to try and draw out that code in UML, as well as talking about maybe additional implementations based off the design pattern there. So I just want to hear some thoughts in terms of which one people want to go down. Do people prefer to talk about grasp patterns in terms of discussing and more of a discussion related thing? Or do you want to talk about more design pattern related? Okay, here's an example of design pattern. What would look like if we were to extend upon it?
First one,
First one.
yes.
Okay.
I've also done the same exam and I feel like that one was more challenging.
Yeah.
But
Cool. Was that a hand up there too?
Oh, I was gonna say, something, but just to add on to that, I guess I was a little confused as to like, I remember it was like a 10-part question. About that, so I was like, where are they coming from?
Yeah, okay, sure thing. We can talk about this now then. Okay, are there any other people that were particularly keen on discussing the design pattern one as well? Or otherwise we can just focus on discussing this grasp pattern one instead. Cool, let's get started then. I guess for this type of question, it's always really important to actually go through and understand what exactly the existing content is. So let's actually talk through it. So at the moment, it looks like we're at this burger chain that we're trying to implement a new ordering system. So at the moment, you can see that there's some requirements. Let's identify what exactly are our requirements. So they're trying to say that they're trying to implement this build your own feature, where that in the case, they can go about allowing customers to build their own burger by, I don't know, by creating whatever different types of sauces, I don't know, beef patties, burgers, patties, whatever they like in terms of it. So they can be created through different combinations of bread, patties, vegetables, and sauces. When it's selected for a burger, it needs to instantly calculate the total calories, its price as well. So it needs to be able to calculate everything in that particular case. And they say there's a couple of limitations. One burger can have multiple patties, vegetables, and sauces. So we see that in the existing implementation that we have we're using the compositional relationship where we have some particular thing called a burger. And then it looks like at this very moment, we have 4 separate attributes, each relating to, I guess, all different types of things that we have. We have white bread, beef patty, lettuce, and barbecue sauce, I'm assuming that it's talking about there. Okay, so the question is asking us, what exactly, based on this, okay, are some design concerns based off of the existing implementation and the upcoming bring your own feature? Okay, so I guess my first question to you guys in terms of this sense is that at the moment, is there any particular code reuse or code smell that you guys are seeing at the very first beginning here? Do you guys see any commonalities between those 4 ingredients that we have here? I'm seeing a couple of nods. Yes, exactly, right? We see all of them have the exact same get calorie and get price methods, which all perform essentially the exact same thing. Okay, can anyone tell me what, in terms of the design implementation, in terms of classes, is there actually any differences between these implementations of get calorie and get price? Is there anything specific to each of them? No, exactly, right? We're introducing all of these new classes for essentially almost no reason at all, right? We're introducing a white bread class, a beef patty class, lettuce class, barbecue class. They all exist as separate attributes within my burger class, but they all essentially do the same thing, which is almost basically hard-coded, returning hard-coded values. We say that the white bun has 4,000 calories per gram and it costs 3 cents per gram, right? And these are all but essentially hard-coded values. So there's a couple of ways that we can go about potentially solving this, okay? And I'm just going to hint at one of them is potentially talking through protected variation. So let's just say that there may be the case of future cases where that we want to add on a new type of sauce, a new type of ingredient. At the moment, what would that look like to go about adding on a new type of ingredient? What would that look like? Can anyone maybe talk through a potential implementation to the existing one?
So you'd have to make a new class for that new ingredient, then you'd have to modify the work with that new class.
Exactly, right? Those are all additional changes that we need to do to ensure that it complies with the existing thing. And on top of that, when we're talking about modifying the existing burger, not only do we need to add in that new attribute to say that, I don't know, I'm going to add in a new attribute called tomato sauce within my burger class. Not only do we need to do that, we also then need to go about into the get total calorie and get total price methods to add in those additional calculations that we additionally did not have before. So this is one of the issues and problems here that we're currently facing. In terms of extendability, this is horrendous. It's working for what it currently is, but extendability is basically non-existent, right? Okay, so this is back referring to that protected variation sort of principle, where that we want to make sure that we are able to change and extend the existing modification without needing to excessively modify the existing implementation. So based off that, does anyone have potentially a solution or a suggestion to maybe collate all of these different similarly typed things together? Yes.
I'm thinking of the decorator, because you just have, if you're do your build your own, you can just progressively add layers to the decorator as much as you need, and then instead of hard coding the price, you can do like, you can also add on the go, because instead of having like beef patty equals whatever it is, you can just add it, so the total price will be calculated based on like base burger object.
Yeah, that could potentially work, especially since it seems that we definitely have the sort of some particular enforcements that we need to have in place. A burger is not a burger if it doesn't have, maybe at the moment it's saying that burger's not a burger without having white bread, lettuce, and barbecue, it seems like.
Yeah.
Okay, so those are the things that we need to, yes.
No, I was just also going to call out. So the question does ask for instantly calculate. Right. So that's a one-time implication.
Yeah. On top of that, I guess, in talking about that, when we're talking adding in the decorator pattern, if we were to try and go about implementing it, there is also other considerations that we need to also have, is that if we were to try and decorate this, okay, going back, I don't know if I don't have the slide up from decorator design pattern, but the decorator, as part of the decorator design pattern, we need to make sure that all of our different classes are related to each other in some particular way. We can't just, I can't just decorate the burger as is, right? Okay, there are additional things that we need to do. One of them would probably be creating some particular parent class, let's call it ingredients, some particular type, okay? And then maybe just, I'll throw it to the audience, what particular methods could we potentially define within that parent class? Throw it out there.
How we get price?
Done, easy as that, right? Okay, you would define those in the parent class. It doesn't necessarily have to be a parent class. It could be an interface in this particular case, okay? And then the burger class would be wrapping around it, okay? We would define some particular base case. That would be the white bread, lettuce, and barbecue, okay? And then at runtime, we can go about adding different cases as we need there. Sorry, did you have any questions? No, yeah, all thinking. All good, okay? Any questions before I continue along or yapping along? Yes?
Could you use the composite pattern?
Composite pattern, but trying to think of downsides to composite here. Something to note about the composite design pattern, I think it's a very common misconception with the composite design pattern, is that the composite pattern in implementation looks extremely similar to the decorator design pattern. Okay, but I just want to call out a couple of things on points of difference. Okay, the decorator design pattern, okay, follows a very sort of like chained manner, whether it's a Russian doll, whether it's one thing decorating another thing. It is basically a one-to-one relation pretty much the whole entire way. But the thing is, with the composite design pattern, most of the time for a composite design pattern, it follows a very much like tree-like structure. Whether you have some particular base case, some base node at the very top, but you're not restricted to just decorating or composing one other thing. It can follow something like, I don't know, you could think of the hierarchy within an army, for example. You would have some commander at the very top, okay, and it would split down to 5 separate nodes, and each of those different nodes would have a bunch of other different nodes. So the composite design pattern here could potentially work, but in this case, I wouldn't actually use it. This particular burger doesn't exactly follow that sort of tree-like structure, okay? Yeah, it could potentially work, may not work. In terms of implementation, not too important there. The main thing that we need to address here is the cases of protective variation, which is one of the most important things here, okay? And there's probably some other things that we need to address too. Yep.
We also throw in there that thing about third-party market system. We just kind of ignore that.
Third-party markets.
So under possible ingredients, patty, and then in the bracket there it says calories and cost retrieved from the third-party market system.
Oh, well, there you go. Okay, sorry. Then that kind of enforces our facts of the fact that we can't actually just have these as hard-coded values everywhere. Because one of the things that one super janky solution to this, if all of these were potentially, let's say, hard-coded values, okay, could anyone potentially suggest another solution? Let's say we know as a fact that all of these patties, bread patties, vegetable sauces, all have predefined, I guess, costs and calorie definitions. What's a super easy way and janky solution to get that working? Sorry? Template?
Or strategy.
I was thinking even simpler. Literally, there would probably be just a lookup of some particular kind where you have a list or maybe strings even, but they just look it up. If it's all hard-coded and predefined previously, again, there is no problem there. If it's all hard-coded, then you would just go about doing that. But I guess talking about that second implementation where it talks about the third party, it enforces the fact that, hey, we need to go about actually looking this up. There is a method that is involved. Yes?
The name, calories, price.
Email.
That's all hard enumeration.
Yeah, that works completely, right? Okay, so having that, that's what I mean by hard-coded. Okay, I'm including enums within that particular case as well. Okay, because I guess enums are, predefined hard-coded values where you would have maybe potentially even having white bread, and then as part of white bread, you would have the calories and costs associated with it. Okay, cool. Any questions before we move on to the second part of this question? Yes.
You mentioned that each problem in the exam has one solution for the design, like the design pattern, which should be, what would it be in this case?
Gonna make me eat my words pretty quickly.
Well, would we still get some marks if we like?
I was about to say, yeah, as part of this, I might eat Rob's words and say that in this particular case, there probably isn't a single solution to this. in terms of there probably will be, I don't know, it depends on how you go about using those different design patterns. So in this case, for me, like the very first clear case I'm seeing is that either going for the composite or decorated design patterns. That would be the first thought that would go to mind. But of course, if you were to go about this and trying to design this in a bigger, different system, whether you're thinking about, I don't know, other people, other services, maybe the cashier service or something, going about trying to come in to calculate the burger's total price and calories, maybe the strategy could come in to fit in somewhere. Okay, I'm not particularly sure in terms of it goes about how you want to go about implementing it as well. Okay, so I'm more than happy to sort of talk through, maybe like, let's say you guys suggest that, hey, I want to use the strategy design pattern somewhere in this particular case. Okay, it comes down to how you go about arguing and implementing it as well. Do you have any other thoughts on that, Rob?
Maybe we can talk about it next. I don't want to disagree, but yeah.
Yeah. Oh, well, there you go. Next question. Which of the 9 Gang of 4 design patterns taught in this subject will be best suited to support the future extension? Justify why the identified pattern is best suited and how this pattern can resolve the stated concerns. I guess which directly brings up to your point.
So I think what's maybe important here, there's some design patterns that aren't suitable, right? And let's quickly talk about composite versus decorator. Can someone tell me why one is suitable and one is not? And it's probably like the key is here. So one burger can be made of a combination of bread, patties, vegetables, and sauces. And then in the examples, we've got a bread, we've got a patty, we've got a vegetable, and we've got a sauce. So we know that it's always going to have some, right? Like, is the assumption here that you'll always have bread, so there's a base case, or is the assumption that you'll have different combinations, so you can have a burger without bread? Like, because that kind of determines which pattern you can use and which you can't. Yeah.
The base case has to be conform.
Yeah.
So you've already decorated. Adding components.
Yeah, correct. So I think like for that reason, it's kind of leading you down a path because there's conditions that always have to be met.
I'm eating my own words here. Sorry, I'm going to eat my own words and say that both decorator and potentially composite both don't particularly work for this particular case. I would argue that just to reach, for the sake of reaching an answer, the builder pattern will be the most suitable for this particular case, especially since we have different variations of a particular thing and we have to enforce particular combinations. The builder pattern will be the best to go about resolving the different facts that you can have and add on different things and different features. It also allows you to validate, okay, the fact that you have reached particular combinations. And on top of that, I guess on top of talking about builder, you would also need to make sure that not only are you implementing the builder design pattern to help implement this particular feature, you also ensure that, I guess on top of that, those different white bread, beef patty, lettuce, barbecue, okay, you actually go about creating parent classes or a common class to go about collating all the ingredient information that you have to instantly calculate the total calories and total price within your burger class as a whole. Okay, so that, I guess, again, supports that future extendability that we're really looking for within this class. And that is to be able to fact that, let's say in the future that we do want to go about creating new sources, adding new sources, whatever the case, okay, there is minimal changes that we need to do from our end. Let's say that we create a new tomato sauce class. If it inherits from the ingredients parent class, then we're sorted in this particular case. Yes. I would definitely state it as a definitely thing. I think this is something maybe potentially they're looking for within the question for you to imply based off reading the UML diagram. Because the UML diagram is something that, I mean, based off reading it right there, it explicitly states that the white bread, lettuce, and barbecue are things that are associated with the burger. And it doesn't state that within the textual description. I would definitely state that within your answer there. Yes. Oh, okay. Yeah, no worries. Okay. So talking about this, I guess we'll quickly wrap up on this end. Okay. So on the last question that we have, draw a UML design class. Okay. So this one is, I guess, based on time, do people want us to go through potentially drawing a UML diagram of a potential solution here? Cool. All right. So let's get going with a potential solution. So ignore this question. All right. So let's define at the very top here. We'll have some, no. Let's talk through burger. Okay. So we'll have this burger class on the very top level, and then we'll need to create separate classes for different types of bread, different types of patties. What was it? Lettuce and sauces. Let's just call it sauces for now. Okay. So we'll have, at the moment, this is its current implementation based off the different compositions that we have in this particular case. Okay. And we mentioned just before that in order to actually go about helping the calculation of these things, this is not exactly the structure that we're looking for. Right? At the moment, these are 4 separate ingredients with totally 4 unrelated method signatures that are somehow supposed to collate together. So instead, can anyone potentially suggest maybe a name for a potential solution here? What should we go about doing to make sure that these 4 ingredients can actually be related to each other and used in a similar particular way?
Create an abstract parent for ingredient.
Yes, creating an abstract parent class that is potentially called ingredients that would contain all those necessary methods or attributes that we need in this particular case. So in this case, what I'm seeing and foreseeing here, maybe someone who maybe have a better solution than me as well, okay, I'll be creating a separate ingredients parent class, okay, which would instead be utilized by the burger class and to have a list of ingredients in this particular case. Okay, so each of these, I know I'm drawing the arrows wrong in this particular case. Instead, these arrows should be flipped around and should have the white arrowhead instead. Okay, but this is the rough solution in terms of what I should be going about, structuring my burger class at the very least. Okay, so here is the rough structure that we should go about following. Okay, so in here in this ingredients class, I'm just going to crudely define the methods that we need. So get calories. And it returns a double for this, and then get price. And let's just, for this sake, let's also return a double. Okay, so this is roughly what would look like in terms of implementation, UML implementation for the ingredients class. And all those subclasses would then go about implementing those specific methods as well. So on top of that, okay, so based off this diagram alone, how do you guys potentially see the burger class actually going about calculating the calories and prices? So we have now this ingredients abstract parent class, which will have two methods available to us. That is get calories, get price. Each of the different sources, ingredients would have different implementations of it, but they all achieve the same goal of calculating calories and prices. How would then the burger class go about calculating its total calories and its total price? Now we're talking about implementation here. So again, we saw that there is a method defined in the burger class that says get total calories. So this we can keep as is, okay? But I'm just wondering, what would it look like within this method itself?
It loops over all the ingredients, pulls, get calories, and so on.
Simple as that, right? Okay, we understand that because we've defined that this has an ingredient parent class. Instead, I'm not noting it down because again, it is implied through this association here between burger and ingredients that there would be a list of ingredients within burger. This get total calories and the same thing for the get total price as well would essentially just be going through that list and calling the get price and get calories for each of those. Okay. So to talk about the builder pattern itself, the builder pattern to be going and talking about implementation here would be a totally separate class. This would be, let's just call it the burger builder pattern. I don't know, just naming's sake, maybe someone else can come up with a better name. Okay, so in this particular case, the burger builder essentially would need to have a couple of methods that we need to define. We need to define, first of all, of course, the constructor itself, which would, I don't know, return the, I don't know, let's call new builder, which would return a new instance of the new burger builder itself. Can anyone maybe mention what particular set methods we will need to have in this particular case?
Set patty.
Set patty, easy as that. Okay, so we'll go on the list, okay, in terms of set patty. This would take in a patty in terms of as one of its arguments, and then the list would go on in terms of sets. Lettuce, take some lettuce. And I'm not going to continue listing them on, okay? But the idea is that these set methods would continue on all the way until we've listed them all out. So in terms of set bread, lettuce, patties, burger, and sauces. And at the very end, there will be a build method, which would actually go about instantiating that object itself, okay, returning to you that final burger object back to you, including validations and everything along with it. Okay, so we can talk about it through this particular case. So coming back to our grasp principles, okay, how have we improved our design when we've incorporated both the burger builder itself and the ingredients class? Okay, so I'm thinking of, there are two particular principles that are standing out in my head. Yes? Yeah, exactly. So extendability, okay, becomes a lot easier. So again, that's talking about the protected variation principle. Okay, so again, if we want to go about adding white bread, wholemeal bread, I don't know, the new bread, maybe, I don't know, gluten-free bread as an example, okay, there will maybe potentially come as subclasses under the bread, okay, bread class there. Okay, so that would work completely fine. But on top of that, okay, I'm thinking of another issue, another principle relating to creation. Okay. This is specifically the creator principle, which is exactly the whole point of the builder class, right? Okay, the whole idea behind the builder class is that now we have a specific class handling creation logic. We've just talked about just then that there is some logic and rules that we need to follow when we go about building a burger, right? Okay, we need to ensure that there is always a bread, lettuce, and sauces. Okay, at the very minimum, okay, you can go about adding and setting new things on top of that, but there is a minimum and we can go about enforcing those things within those methods itself. Okay, those set methods may not just be as simple as set patty, there could be additional if checks, okay, to ensure that we have met the required business logic from our end for this case. Okay, cool. Any last questions about this particular case? I know this diagram is very crudely drawn. Okay, I know I've tried to follow as many of the UML principles as I can. Please do note, I know a lot of these arrows may be wrong. Okay, cool. Yes?
Getting your ingredients still need to add into the burger builder?
Not necessarily if we're following the same bread, patties, lettuce, sauces combo. Okay, you'll be utilizing the same, let's say you would go onto patties and you go maybe beef patty, chicken patty, and there'll be subclasses of the patty class. If you were to go about adding like, I don't know, a new not condiments, but like extra additional things, such as maybe adding bacon to this particular case, then yes, you are right. Okay, not quite protected variation. Okay, you would still need to go about creating a new ingredient subclass, a new set of method. Okay, but at least for these, at least 4 subcases, it is protected variation. Have a question there?
Yeah, because like differences between each kind of category. So also whatever the difference is so small. So
Yep.
you're using external service like query and calories.
Yep.
Wouldn't it also make sense to just define like an ingredient class and then within that class you say store a name and then like an endpoint, like a way to look up the external service. Because then like if you do it like this, you're gonna still say down in the future need to define potentially hundreds of classes that each just store like a very small amount of information.
No, totally agreed, right? This is why I've mentioned before in terms of like, let's say that, I don't know, at the moment, it is quite simplistic use cases, right? Most of these ingredients, for at least bread, lettuce, and sauces, are literally just storing a value and then returning the value itself. So that's why I initially said that most of the time in this particular case, an enum will be completely justified to go about defining all these cases. And then maybe on a specific case, okay, you would be essentially looking it up. Yes, you are correct. Okay, but it is only for this particular case I'm saying that this would work, okay, only for the fact that there is external lookup. And if in the case there are future cases where that there is also additional logic in terms of additional third-party lookups, maybe there's additional, I don't know. The idea here is that we allow for that variation to exist if it occurs. But of course, this is blowing things a little bit out of whack, like a bit more design than maybe necessarily need, but up for discussion as well. Cool. Mitch, thank you.
Just want to say thank you, Charlie and Rob, for presenting. Um, and thank you all for coming. I hope you got something out of it. I'll just pull. I hate Max. Quick. I don't know how to use it. Just the next one, yeah. Thank you. So if you have time, we'd really appreciate if you'd scan the feedback form. We do these workshops every semester, and feedback's really helpful for making the next ones even better. Once again, there's our link tree in the middle. And on the right is a download link to the slides, which didn't actually get used today, but there is plenty of useful information in there. So if you do want to download them, they're available there.
Can I just quickly add? So I had some questions about the Excalibur. What we've done is just on this recap, this is a link to that Excalibur. So if you download the slides, you can press this button and then you'll get that madness that we talked about. So hopefully that makes sense as well.
Oh, as well, now that I talked about it, I mentioned it in the Zoom chat, so people on Zoom would probably have seen it. But at the I can't even see it, I'll share it. But later on, there is these, when me and Rob tutored this subject like years ago, we created some workshop slides, which I don't know if they're still being used today in workshops. But the idea is that, okay, I'll share it once in the Google, here we go. Let's see if we can pull it up. This one. Okay, so I've actually uploaded these to a GitHub repo, which essentially go through all the workshops that you guys have had. Okay, so let's take workshop 1 as an example, when we talk about use cases. Okay, you might have seen these slides somewhere around. I don't know if you guys have or have not, but these are the workshop slides that we created a while back. Hopefully they might be a little outdated, but hopefully the content is largely roughly the same. You guys are more than welcome to try and use this as revision material to go through and maybe double check some of the things that you guys may or may not understand. Okay, just an additional resource to throw out there. But yeah, best of luck with the exams, guys.
Yeah.